So now that we have the cosine squared, we can do a little substitution. So that is a squared over a squared plus x squared. This much, remember, is just for the cosine. We also have this over a squared, and we get it a little nice pretty canceling out of that. So our derivative is then 1 over a squared plus x squared. So if that's our derivative, we can work backwards for our integral then. So if I want the integral of 1 over a squared plus x squared times dx, this must be our antiderivative. So 1 over a arctangent x over a plus some arbitrary constant. Arcsecant you can do in a similar manner. For time, we're going to sort of skip over that. If you have trouble with it, just let me know. Okay, so I'm going to play with a couple of these. We'll do integral of 4 over root x 15 minus 2 root x, all of that times dx. So the best option on this one is just a little bit of a simple u substitution. Let u equal 15 minus 2x to the half. So then du, negative 2 times a half times x to the negative 1/2 times dx, and we can do a little cleanup there. So negative x to the negative half times dx. So then what we have and what we don't, looks like we have an x to the negative 1/2, but this square root of x parked downstairs. It looks like we don't have the negative that we need. Multiply inside and outside by a negative 1. We also have that 4. We can bring him outside. So integral of du over u. So negative 4 integral du over u. So that's negative 4 natural log absolute value of u. So then that is negative 4 natural log of 15 minus 2 root x. Close it on up. And of course, our plus c's once we get rid of our indefinite integral. You might see it this way, or you may see it with the negative 4 then as an exponent as well. So you might also see it natural log 15 minus 2 root x to the negative 4th power plus c. Either one of those are okay. Okay, so next one, we have a little splitting up to do. So we'll do integral of 3x plus 2 upstairs, root 25 minus x squared downstairs, and of course our friend the dx attached. So one thing we can do is split this. So if they have a common denominator, we have a right to split the fraction. So if we look at our first fraction, if we do u as 25 minus x squared, we have a chance of getting a du that would be useful to us here, negative 2x dx. This other guy, we're going to have another little idea here. So this one, we're recognizing that we're sort of similar to something that is of the form 1 over square root of a squared minus x squared. So both of them, as you can see at the top, need a little bit of adjusting though. So on this one, I've got a 3 inside. I don't want it. I'll move that outside. I don't have a -2 inside, so I'll multiply by 1. So -2 and -1/2, respectively. All right, trying to basically match the format that we saw before of the arc sine. So that one I just had to pull a 2. So we have -3/2 integral of u to the -1/2 times du plus 2 times arc sine of x over 5 plus c, and then we'll just take care of this integration, finish it off. So -3/2, hang on to that guy, u to the -1/2 is now u to the +1/2, which means I'll need a 2 out here, bring the rest of this along. U, remember, is 25 minus x squared. So that's as far as we can take that one. So some integrals we will have to do a little bit of splitting to make it a little bit simpler. Occasionally, it's something just as simple though as using division. So if I want integral of x squared over x minus 3 times dx, we can simply use division to turn this into an easier integral. If you'd like, you can even use synthetic division here. So 3 outside, 1, 0, and 0, second power coefficient, first power coefficient, constant coefficient. So then remainder constant, first power. So now I've turned this integral into x plus 3 plus 9 over x minus 3 times dx. So this one, a little bit easier to work with then. Antiderivative of x, half x squared. Antiderivative of 3, 3x. And hopefully you recognize this guy as a natural log. So you may see it written that way. You may see it written with that 9 taken care of. Either of those last two, again, are just fine with me. So sometimes a little bit of synthetic division, sometimes a little bit of multiplication by 1. So if we have integral of, say, 36 over e to the opposite of x plus 1 times dx, it's a little bit easier working with e to the x when there's a fraction if we have either e to the x only at the top, or if we have it top and bottom to do a little u substitution. So to take care of that, I'll multiply top and bottom by e to the x. So we've multiplied by 1. We've changed the look, but not what it's worth. So we have integral of 36 e to the x dx over e to the x times e to the opposite of x. Hopefully you recognize that as being a 1. So 1 plus e to the x downstairs. So now we can do a little just u substitution. U is 1 plus e to the x, so du is, of course, then e to the x times dx. I've got everything in place except for that 36. I'm going to scooch him outside. So that's 36 integral of du over u. So 36 natural log absolute value of u plus c. So 36 natural log, replacing u with 1 plus e to the x plus c. Now, just as a little tip when you're looking at what our author's graduate assistant has done in the solution set, occasionally for one like this, he'll lose the absolute value. The only reason for that being e to the x is always non-negative, 1 is non-negative, add two non-negatives together, your solution is still non-negative. So this one he may write without the absolute value, just because the opportunity presented itself, since this is true for, this is greater than 0 for all x. All right, play with a little bit of a trig guy next. So integral of 5 tangent x times natural log, that is an ugly natural log of cosine x times dx. If we let u equal a natural log of cosine x, then du would be derivative cosine negative sine, original cosine x, and times dx. Well, sine over cosine is tangent, so du then would be minus tan x dx. So we have the tangent x, we don't have the minus. So we'll just move that 5 out there and multiply inside and outside by a negative 1. So negative 5 integral minus tangent x, natural log cosine x times dx. Now we're set up how we want to be. So negative 5 integral of u times du. So parts in red here are the du part. So this is negative 5 halves u squared plus c, and then just drop our original back in. So notice it's not the cosine squared, it's the entire quantity natural log cosine x that is being squared. Okay, and one other common technique to make this look more like familiar territory, integral of 6dx over 6 plus e to the x. So on this guy, if I hit top and bottom with e to the x, I get an e to the 2x downstairs and an e to the x by itself upstairs. Not as helpful. But on this one, we can actually do a little mathematical sleight of hand of adding 0. We can always multiply by 1. We can always add 0. So notice here I've added and subtracted e to the x. We've added something worth 0. I'm going to regroup it a little bit different though. So we'll have this as integral of 6 plus e to the x over 6 plus e to the x times dx plus integral of minus e to the x over 6 plus e to the x times dx. So again, if they have a common denominator, you have a right to split the fraction if you'd like. So our problem is now integral of dx. If you want, you can put a 1 there. You don't have to. Minus integral of e to the x over 6 plus e to the x times dx. Hopefully you recognize this guy as another prime opportunity for a natural log. If you need to write out the substitution, that's fine. U is 6 plus e to the x, so du is e to the x times dx. So we have x plus c for this guy. Antiderivative of a constant is a linear. Minus integral of du over u. So x plus c minus natural log absolute value of u. We already have a plus c, we don't need another. So x minus natural log, plug the 6 plus e to the x back in, and plus c will toss him down at the end of the line. All right, so a lot of this is just sort of trial and error, trying to make it look as close as you can to something that we've seen before. Let's see. Do integral of 3d theta over cosine theta minus 1. And this one we'll do another multiply by 1. This time we'll use the conjugate. Occasionally a conjugate will come up that's useful. So we'll do cosine theta minus 1. So cosine theta plus 1 would be the conjugate. And we'll hit that top and bottom, of course. So we have integral of 3 times cosine theta plus 1 d theta upstairs. Downstairs, foiling out here, cosine squared plus cosine theta minus cosine theta, those drop, and then a minus 1 there. Cosine theta, if you'll recall, is also 1 minus, cosine squared theta is 1 minus sine squared theta. So 1 minus 1, those will drop. I can also pull this negative 3 then, the negative from here, the 3 from upstairs. Cosine theta plus 1 times d theta over sine squared theta. And another u substitution. If u is sine theta, du is cosine theta d theta. So I'll hang on to this negative 3, and we'll go ahead and split the fraction. So our little trig work that we did back in your pre-calc days, cosine over sine is cotangent. And 1 over sine is cosecant. Sine squared at the bottom leads us to cosecant squared. And then each of these are substitutions that we've got in our chart. And my apologies, we didn't actually need the, you can have them, don't necessarily need them. So integral of cosecant theta cotangent theta is negative cosecant theta. And from your chart, integral of cosecant squared is cotangent minus cotangent. So we have 3 cosecant theta plus 3 cotangent theta plus c. And there's a few different ways. Sometimes, again, the folks writing the keys to this get a little bit creative with how they express this. So they may say, okay, this is 3 times 1 over sine theta plus 3 times cotangent, remember, is the reciprocal of tangent. So then that is cosine over sine. And we'd say, okay, we have a common denominator. And write it this way. You can write it that way. You don't necessarily need to. This version is fine, so is this version. But just when you're doing your homework, just be aware of that occasionally the author's gotten a little creative with how he expresses his final answers. And to finish things off, just a couple more of these. Occasionally we complete the square to make it look like something we recognize. So if they give us something like integral of 38 dx over square root of 6x minus x squared, we do have some things that have perfect squares down at the bottom. So let's go ahead and grab that 38 out of there, and we'll go ahead and try to complete the square underneath this square root. So first off, we want a leading coefficient of 1 on our squared term. We don't have that. Let's factor the negative 1. Okay, so now that we have that, half of b is negative 3. Negative 3 squared, positive 9. I'm going to write a plus 9, but remember with this negative 1 out front here, that's really subtracting 9 that I've done. So I will have to then add 9. So now we've got 38 integral of dx over square root of 9 minus x minus 3 quantity squared. So the closest one in this in your table would be integral of du over square root of a squared minus u squared, which was, if you'll recall, arc sine of u over a plus c. So here our u isn't just a single thing, it's a quantity x minus 3. A, of course, then being a 3, since we have 9 is the same as 3 squared. So we have 38 arc sine of x minus 3 over 3 plus c, plus an arbitrary constant. So we do occasionally have to complete the square. And we'll do one quick diffq, differential equation, and then we'll call it a section. So let's see, which one do I want to do? We'll do that one. So we'll say that dr dt is 3e to the t dt over square root of 1 minus e to the 2t. So then r would be 3 times the integral of e to the t dt over square root of 1 minus e to the t squared. So power to a power, we multiply. And I'm trying to make it look like something that we have that's more familiar. If I let u equal e to the t, du, of course, is e to the t times dt. And that looks familiar then. So r is 3 integral of e to the t dt is now du, square root of 1 minus u squared. So this one should look familiar. That's our friendly arc sine again. So then r is 3 times the arc sine of u over, in this case, 1. A squared is 1 squared, or just 1, plus c. And then we just do our little back substitution. So r is 3 arc sine of e to the t plus c. Okay, so some problems to try out from 8-1, 1 to 51 odd, 59, 61, and 65 to 71 the odds. If you have any questions, please get in touch with me. Otherwise, stay safe out there.